Hi class, welcome to exercise 8. This will be our second installment in the horizontal mill series. If you notice, we've changed up the machine just a little bit here. I've added a tombstone and one vise, and we have a new part. This part is 4-sided. We are going to do the first 3 sides in this exercise, and on the next exercise I have a surprise for you. Well, let's take a quick look at the machine. I made the door a little bit transparent, make it a little easier for you. This is an Akuma MB5000H. And you can see a little bit better where that tombstone sits. This is called a tombstone right here. You can see a little bit better where that sits on our pallet. And we can have another pallet on the other side ready to change over as well. Maybe that's something we'll incorporate into the next exercise. We have a spindle there, and we are all set up. I've pre-laid out all the chains and work coordinates, so we're ready to start rolling. We're going to start on roughing out the part from the stock, so we can turn the stock on here and you can see what the stock looks like, and of course there's the part. And we're going to start chunking away material here. Alright, so we're going to go ahead and start removing material. I'm going to go up to my stock chain. I'm going to go over to my pocketing command. I'm going to call this rough profile. We're going to use our 1.5" face mill. If you notice on the tool list here, I brought in actually tools from the library of my own shop to make this part, and I programmed it as I would make it here. So it's better to give you the real world experience as best I can. Strategy tab. Pocket tab. The key thing to know here is that we are using both the lower profile and the center boundary. So we're going to cut between the stock profile, which is the dashed line here, and these two highlighted green lines. Going to be ripping it up pretty good. And we're leaving 25 thou and 25 thou. And that's it. So I'm going to let this run. I'm going to step into the simulator now. Because we're in a little bit different machine here, the pallet is actually moving. And I'm going to turn that off so we can see what we're doing. The pallet is moving in Z, and the head is moving in X and Y. So this is a horizontal machine center. It is not a horizontal boring mill, and if it was a boring mill, the head or the quill would be able to move in Z as well. So you see it shimmy a little bit there. That's the Z actually moving. Give you a better idea. So we want to do fast material removal, light fast bites, light depths, pretty decent step overs, extremely fast aggressive speeds and feeds, high pressure through spindle coolant. And I use this method on a daily, and it produces nice chips. It's easy to evacuate from the machine, and you can really go pretty fast. So just kind of give you an idea, we still got plenty of stock on there. And next up, we're going to do a profile operation on the center boundary. So I'm going to go up top here to my contour. I'm going to do a finish profile. Use my 1.5" feed mill. I'm going to slow it down a little bit to 7,500 RPMs, get a little bit of chatter out of the tool. And we're going to go at 3.5 thou. Strategy is going to be one pass. We're going to allow 25 thou for the floor because I'm going to come back and do the floor later. Going to go down to increment of 50 thou. Everything looks good there. Remember your lead out radius. So the tool is 1.5", so I'm giving myself another 1/4 inch on top of that for my distance. I'm just going to go and simulate. See, it looks like a really large lead here, but when you actually run it, you'll see how it moves into the part. The Akuma Control is going to do an immediate comp, so it's going to instantly comp the tool here. And you can see that value if you're cognizant of your Cartesian coordinates. So you can see it moved in, and there's a little bit of a movement there and a little bit of an arc. That scars start moving around. I'll turn them back on so you can watch it. If you want to dial that lead in, I'll show you a trick here. You can change it to a normal and tangent, and it'll actually start out off the side and work its way around. Now this tool is just a little bit over 3/4 inch because this is actual measurement. So if you look at the tool itself, it's just 2.5 tenths over. So I just round up a little bit because this is only for lead. But I'll do a normal distance, and I'll do the tangent distance, just a little bit more than that. And I'll show you what that looks like here. So it's going to come down. I'll hide the spindle here. It's going to position Z. It's going to make a shift. So it just did the lead right there, but it was so small that it looked like a straight line. And that way your lead is done while you're out of the part, and you can come straight into it. You'll never see any blend line. A little trick of the trade, I guess. I'll try to slow it down here so you can see it exit the part. So you can see when it went to exit, it actually just continued past the part and went out, so there was no chance for a burr. Alright, and we got those sides done. Next up, we're going to go ahead and finish the lower face. So same chain, different operation, different type of operation. Still going to use a contouring, but we're going to use it as a facing operation. We're just going to run the face mill around the edge here because our face mill is wider than the material that's left right here, so we can take it off on one chunk and get a really nice finish with no crossover lines, no witness marks. And again, we use the normal and tangent to manipulate that lead in. Nice clean exit. Oh, maybe not. Yep, we're good. Nice clean exit. No lines. Beautiful. Alright, getting there. Alright, so the next thing we're going to do is rough out the center material. And we're going to use our 1.5 inch feed mill one more time. I'm going to go to my rough pocket. I'm going to go top here to solid mill traditional. And I'm going to go over to my contouring operation. I'm going to call this rough pocket. I'm going to leave 25 thou on the wall and the floor. I don't want to touch this freshly faced surface down here, and I don't want to touch the walls. I'm going to chase that with a different tool in just a little bit. Pay attention to your lead in, lead outs. You can see why we wanted to pay attention to those leads. You have a really tight space to work with. Now we did make the chain larger, so that we have room for the tool to navigate outside in the air. Um, but we do need to mine the leads. So you see it's going to come down and it's going to comp over and then through. And then comp out. So that's nice. Got a little bit of material here to clean up. Alright, so now we can do the ID pocket. Alright, so we're going to stop the simulator, and I'm going to go to my ID pocket chain. I'm going to go up top to a pocketing command. I'm going to call this rough pocket. I'm going to use a 1/2 inch helical, which is a bull nose end mill, BULL. It's going to have a 15th radius in the corners. And it's designed specifically for what we want to do here. So the shank of the tool is necked, so it's smaller than the actual cutting diameter of the tool, and that allows us to reach deeper and not encounter any chatter issues that you'd get with a fully fluted end mill. So this is solid carbide through and through. Looks good. Slow us down just a little bit. I'm going to helix down, and then we're going to work our way out into the material. Helixing is actually one of the most efficient ways to remove material. Alright, so we're ready to go ahead and chase that with a finish pass. So I'm going to use the same chain, same contouring operation. I'm going to call this finish ID. You can see a little bit better the geometry of that end mill. Pretty handy. I have quite a few of them. It's going to arc in and start working its way around. So as it works down through, the material that it already cut is getting ever so slightly recut by the top of the tool, which is just going to be a little bit sharper in some cases. But nonetheless, any deflection that you would normally have will not be present. The other nice thing is because they're spiraling down, there's contact on the tool on the side of the cutting and the bottom of the cutting tool, so that's helping with chatter quite a bit as well. Alright, that looks good. Next up, we're going to go ahead and drill the holes out here. So I'm going to highlight my 1/2 inch bolt hole point top. I'm going to go up top to solid mill traditional, and I'm going to grab my drilling operation. I'm just going to use a 3/8 inch drill. This is basically just a clearance hole for my boring operation that's going to come next. Go ahead and run that through the simulator. Good deal. And then we'll go ahead and finish those bores. So I'm going to go up top here to my bore, and I'm going to highlight all of them at the same time so that I don't have to do this 4 times in a row. And I'm going to go up here to Solid Mill Traditional and grab my contouring operation. I'm going to call this Finish Bore. I'm going to use my 3/8 inch end mill, which is an ER16 holder. That way we have the clearance, we don't hit the side of the part. And we can really ramp this pretty fast. Actually, the faster you go, the better. You can tell if you're going too fast because you'll have chatter. If you're going too slow, it'll look, I don't want to say burned, but it'll look darkened, blackened, because you're putting heat in the part. So there's definitely an art to it. Just make sure we have the right, this is tool 220, make sure we have the right offset. Good to go there. And there we go. That's the best way to get a clean on-sized hole. Drills will walk, and drills can score, but a spiral contour operation like this, as long as you got your feeds dialed in, will never fail you. I'll hold 1/1000 positional accuracy all day long. I could probably split that down to tenths, because you don't have a chance for the tool to go anywhere because it's constantly engaged in a circular motion. It just keeps it centered on its center axis. Okay, so that's good there. We're going to go ahead and clean the edge up just a little bit. So again, I'm going to highlight the same 4 chains, go back up to my contouring operation. This time I'm going to do chamfer, and this is an extended chamfer holder, so it's sticking out a little bit. But we'll need that reach. And you can see we have it in a ER16 holder as well. I've actually made a bunch of parts similar to this, so that's trials and tribulations I had to sort through to get in production. Alright. So I think, let's see here, what are we missing? I think we need to do the profile yet. Alright, so we need to go ahead and take care of the profile. So I'm going to stop the simulator. I'm going to back over here, and we're going to go to our lower profile, and I'm going to grab contouring operation. Use this 1.5" feed mill one more time, or face mill rather. It works as both. And then what I'm going to do is I'm going to grab that operation just to optimize this. I'm going to go ahead and take that. I'm just left clicking and dragging to reorder it. I'm not dragging on the tool, I'm dragging on the operation. So left click and drag, and I'm just going to bring it right up here. Actually, I'm going to bring it right above there. That'll be just a little bit more optimized as far as tool movement goes. Alright, and that's it for this orientation of the B-axis. So I'm going to go back over to my features. I'm going to cinch that up a little bit, and I'm going to double click on my next work coordinate to make it active, that red box around it. And I'm going to grab my profile here, and I want to clean up the material that's on the outside of this profile. So I'm going to use a contouring operation for that. I'm going to go up to my contouring. I'm going to call this rough and finish profile. I'm going to use a 1/2 inch kind of middle that is 1 inch and 5/8 long. It is square. And I'm going to rip it pretty good. Going to leave 25 thou for finish on the walls. Not concerned about the floors because obviously I'm going past that. Make sure my offset's correct. Slow it down a little bit for the finish pass. And that should be good to go. Go ahead and step into the simulator. We'll take a look-see here in just a second. So get this repositioned. And we're going to see it turn on its side. So if I turn the machine on, you can see what's happening just a little bit better. I'll turn that back off. And we're going to start chunking away material. There we go. Getting there. Alright, so next thing we're going to do is remove that inside pocket material. Stop the simulator. I want to grab my pocket chain here on that 90-degree B-axis rotation. And I'm going to go up top to solid mill and grab another pocketing operation. I'm going to call this rough pocket. Actually, I can call this rough and finish pocket. I'm going to do rough thin walls. I'm going to use a 1/2 inch helical. Go just a little bit past on the depth so we get a good cleanup. Make sure that's going to be 220. You got to keep an eye on your offsets. Make sure you're calling the right tool. Turn to the side again. And we're going to chunk that material out of there. Again, helix down. Work it out. Really nice small chips this way too. Could always drill a starter hole through there if we really wanted to, but this is just as fast. Alright, beautiful. Now I'm going to put a little bit of chamfer on there. So I'm going to back to the same chain. I'm going to do another contouring operation. Use my extended chamfer tool again. Looks good. Alright, so you're going to want to do the same thing that we just did on your -90 position, or 270. So I'm going to go ahead and do that now. And the nice thing is you can just copy and paste that over. Alright, so I'm going to save that. I'm going to run it through from the beginning just to make sure everything's good to go. So we'll do a little outside view here. So that's doing the rough profile, and it's going to do the finished profile, top and bottom. Rough the pocket. Rough and finish the ID. Drilled holes and finished holes. We're going to do the side work. Alright. And that is a mostly finished part. And next time, next exercise here, exercise 9, which is going to be our third horizontal mill exercise, I'm going to show you how to have multiple vices on the tombstone, and we're going to make this part complete. I'm also going to add some chamfers on here, and we're going to start getting into surfacing. Now that said, I did promise you guys I would show you some code. You should have a post processor, and it's just a very basic post processor. This isn't the latest and greatest, but I'm hoping we can get that turned on for us pretty soon here. And you'll get to see a little bit of code. And if you want to look at something a little bit more in detail, you can highlight it, right click, and go to NC code instead of posting everything. Alright, I hope you enjoyed this assignment. I look forward to seeing you guys complete it this week, and I will be in touch with feedback as necessary. Thank you very much.